Hello and welcome back to the channel. Today we're going to show you a beginner's guide on how to get started with Arduino OLED displays. Now OLED, O-L-E-D, stands for Organic Light Emitting Diode. It's basically a thin layer of organic material. It's normally going to be small molecule, a polymer of some sort. And it's going to be sandwiched in between two conductors, typically transparent glass, maybe plastic, and when an electric charge goes through it, it emits light. Now compared to the LCDs that we've used in the past, OLEDs have a better contrast ratio and color reproduction, which makes it great for those sharp, crisp images with good color. And they also have high refresh rates, which make it great for those projects that require fast display updates. OLED displays are great for Arduino projects because they're low power consumption, they're thin and lightweight, and they're easy to use. And they're easy to use because there's a number of libraries that you can use to get you started. And that's what we're going to do today. We're going to look at a couple libraries to help us build a clock with time and date, and we're also going to build a stopwatch. So let's get to it. Here's a look at the OLED display that we'll be using. It is an I2C interface. Now you can get this in a SPI interface as well, but you would add 2 more pins. We have 4 pins. The ground pin, the VCC pin, which has an operating voltage of 3.3 to 5 volt. And today we'll be using 5 volt because the real-time clock module will be running on 5 volts, so just keep it all the same. But you can use 3.3 volt as well, and that's great for other boards such as a Teensy board or even your Raspberry Pi boards which operate on 3.3 volt. Then we have our serial data and serial clock pin as well as part of our I2C protocol. The screen size is 1.96 inches. It's almost an inch. I don't know why they didn't just go for the full inch. It has a screen resolution of 128 by 64 pixels, and it has an operating current of 20 milliamp. So for our first project, we're going to build a clock complete with date and time. So for that, I'm going to use the Arduino Mega. You can use whatever Arduino board you want. I'm going to use the Mega. I'm also going to use the real-time clock module. Now, this is a cheap one. Just got off Amazon or eBay, one of the two. But you can use the internal clock for the Arduino using the millis function, but I'll let you know that does have a tendency to drift. So your time may be off, so you're better off using a real-time clock module. Plus, if you turn it off, it's battery backup, so technically it should continue to keep time. I'm also going to use the OLED display, which we just talked about, and I'm going to use a breadboard power supply. I just got into the habit of powering most everything I use on my Arduino with a power supply, so I think it's a good habit to get into, especially for me, so you don't burn out your Arduino accidentally. You're also going to need some male-to-male jumper wires, and I'm using a half-size breadboard, so that's what we'll use today. As for the connections, you can see that I'm only using 3 pins on my Arduino Mega board. I'm using the serial data and serial clock pin for my I2C connection, and I'm using a ground pin. So I've got everything connected over here on the breadboard. Now as for my modules, I've got both the VCC and the ground pins of both modules connected to my rail right here, which is a 5 volt rail powered by my power supply. Now the SDA pin for my display is connected to the SDA pin for the real-time clock in the same row on the breadboard, which is connected to the SDA pin of my Mega here, and the same for the SCL pin, the serial clock pin. Let me show you a diagram so it's not quite as confusing. In the diagram, it may be easier to tell that I connected the SDA pin of both my modules to one row on the breadboard, and then that same row of the breadboard is connected to pin 20, which is the SDA pin on the Arduino Mega. And I did the same thing for the SCL pins on both my modules. I connected them together in the same row on my breadboard, and then connected a wire from my SCL pin 21 on the Arduino Mega to that same row. Now this particular real-time clock module has another row over here for daisy chaining I2C, but I just did it all on the breadboard. Here's a look at the code we'll be using. We're going to use 3 libraries, so don't forget to include those. We're going to set our display at 128 by 64. And down here, don't forget to put in the address of your real-time clock and the address of your display, which is right here as well. So for your clock setup right here, these numbers, they correspond with the comment right here. So you got your seconds, minutes, hours, days of the week, and the first day of the week is Sunday, the last day of the week is Saturday, which is 7. So you got your days of the week, days of the month, your month and year. So keep that in mind. And it is 1 o'clock, so I'm putting 13 here, and currently 54, so 55 by the time I go ahead and apply this, upload it. And come down here, I've put this on a 12-hour format, so if you don't want that, you just take this section out right here. And I also added AM and PM. If you want 24-hour format, you may not want the AM and PM, so you can take that out here as well. So we're going to go ahead and upload this. There you go. It's 1:55 on 2/28/23. That is how you do the date and the time. Now we're going to go ahead and build a stopwatch, and as you can see, I've already put the buttons on here. I've got 3 buttons. I've got the start button, I've got a pause button, and a reset button. And those buttons are connected to pins 2, 3, and 4. I also have the ground pin of each of these buttons connected to the ground rail here, and then just one ground pin going from the ground rail to my board. I also have the 4 pins from my OLED connected directly to my board. I've got the SCL and the SDA pins connected over here. I've got the ground pin connected right here, and then I'm using a 3.3 volt pin instead of a 5, just because. I'll go ahead and share this diagram with you as well, just so you know exactly what I'm talking about. Well, that's it for this setup, so let's go ahead and take a look at the code. Here's a look at the code. We're just using one Adafruit library. And come down here, I've got start, pause, and reset on pins 2, 3, and 4. And I set them as inputs with an internal pull-up resistor, which we talked about in the last video. And come down here, don't forget to put your address in, your I2C address for your display. That is important. And come down here, and the next thing I want to mention is I included minutes. So after 60 seconds it goes to a minute. If you don't want minutes, you want straight seconds, just delete that part. But this code will be on the Facebook page, and if you need to know how to get there, just check out the description. It'll all be there. So let's go ahead and upload this to our board. Alright, we start out with press button to start message. This is our start button, so press that. That starts our timer. Now we will pause our timer, and we will start our timer again. And now we want to reset our timer, so we'll hit the reset button, push to start, starts it over. Once it hits 60 seconds, it'll go to a minute, just like the code says. There we go. And then we'll go ahead and reset. Alright, that's it. Well, if you found this helpful, be sure to subscribe and click that bell notification button so you know when we post another video. Share it with friends, families, neighbors, nephews, aunts, uncles, everybody, and I'll see you again soon.